All right. Good afternoon, all, and thank you all for signing up to the AeroPM Learning Together program today. My name is Adam Frizzell, and I'm the General Manager here at AeroPM. On behalf of our CEO, Emily Frizzell, I'm excited to be relaunching our Learning Together program today to coincide with the Australian Flight Test Symposium, which is happening in Newcastle in the last week of November. And today we have close to 70 participants dialing in from across Australia to listen to three of AeroPM's most talented flight test experts. Of note, among our 70 participants, I would like to welcome the former Senator for the ACT, Kate Lundy, who currently presides on a number of boards, including the Geospatial Council, NRMA, EOS and CIT here in Canberra, as well as our own AeroPM Advisory Board. I'd also like to welcome retired Air Vice Marshal Mark Skidmore, who was a former Air Commander of Australia and CEO of CASA, and the current chair of both SciTech and Skycraft. Thank you both for dialing in. As many of you are aware, AeroPM has continued to grow our flight test capability since early 2018, and we now have one of the strongest and most capable test and evaluation teams across defence industry and Australia. A large number of our test cohort are US or UK long course qualified test pilots, engineers and system specialists who have served our nation whilst in uniform and now support AeroPM delivering and testing complex capabilities for defence. Today's agenda sees Shane Patch discussing T&E Philosophy in agile acquisition, Andrew Kerle dissecting the competition between speed of relevance and certification, and Wes Dowling reflecting on the importance of good critical operational issues. But first of all, just a little housekeeping. If everyone can please ensure your computer is on mute whilst the experts are presenting. If you have any questions or discussion points, please add your questions to the chat function and include your name if you like, and we'll address it at the end of the presentations. Plus, at the end, I'll open the floor for additional questions for anyone who would like to ask further questions. So, to get the ball rolling, I'd like to transfer control of this presentation across to Shane. So welcome Shane Patch, so handing over to you, Shane.
Great, thank you, Adam. Dale, if you can go to the next slide, please. Well, thanks everybody for taking the time to listen to this presentation. Today, I'm going to talk a bit about a project that I'm involved in and how we're using test and evaluation to sort of inform our decision-making process in a fairly agile sort of manner. As you can see from the subtitle there, the project I'm working on is Maritime Uncrewed Logistics. Next slide, please. So I'll talk a bit about that project. It's an acquisition project under Navy Minor Project 1983, which is sponsored through Navy's Directorate General of Logistics Navy, BG Log N. So what we're trying to do is introduce a capability for maritime logistics using uncrewed systems. Now, what maritime logistics means in this context is sort of more the smaller spares as opposed to bulk goods, but critical spares and parts and that sort of stuff from ship to shore, ship to ship, and shore to ship. And the big driver, of course, is using uncrewed systems because they should be a lot safer and a lot more cost efficient compared to the equivalent. So obviously it's a lot cheaper to operate an uncrewed air vehicle as opposed to a helicopter or a rigid hold inflatable boat. Or even doing a RAS exercise between two ships. That obviously ties up a lot of resources and is quite operationally restrictive. But, of course, the uncrewed system, the maritime environment has its challenges, and operating to the back of a ship is certainly a challenge in terms of, wind and turbulence and ship motion. RF environment's a big one as well. The performance of these systems are generally not the same as what you would get from a large crewed system. And of course, we've got different regulatory constraints around operating uncrewed systems. And I might point out, even though the image shows a multi-rotor UAS. We're also looking at uncrewed surface vessels and underwater vessels. And because of all that, there's a lot of challenges to what we're doing, and we're in this journey of discovery. At this stage, we're in the risk reduction and requirement setting phase of the capability development lifecycle. So we've decided to take a fairly agile, data-driven approach to tease out a lot of the information, a lot of the unknowns at this phase. Dale, next slide, please. So I'd say we're not really taking a very strict agile approach. So it's not like an agile software development project with, you know, the sprints and the teams and all those sorts of activities and user requirements. But it's more of a mindset and an approach to what we're doing. So we'd all be familiar with the typical waterfall model of acquisition, where we spend a lot of time defining requirements. We go out to a contractor, we develop a system, and it comes back. The Defence Force will then test it against those requirements, do a pass-fail, deliver it out, and then go on to the OT&E cycle. For our methodology, we've taken a more of an agile approach, which is to test early and learn fast, and then change direction. So what we're doing is, you know, doing those tests as soon as we can, learning from that, adapting the direction to what we're doing within the project, and then getting out and testing new systems. So we're using it as a learning engine as opposed to a pass-fail gate. Next slide, please, Dale. So within the project, we've sort of got three different types of T&E, and I want to reiterate, this is at the requirements setting and risk reduction phase. So it's early in the capability development lifecycle. So preview T&Es, where we're getting systems, typically commercial off-the-shelf type systems, or really new systems from suppliers, whether they're in Australia and in a couple of cases overseas as well. We're really wanting to just see what these systems are capable of and understand what their performance is. The next type of testing is development TE. So that's where we've got a system, or we've modified a system, or we've enhanced a system, and we're trying out new things. It's classical development T&E. And then the last one is operational assessment. So this is not to be confused with OT&E, which is more at the end of the capability development lifecycle. This is a matter of putting these prototype systems and developmental systems into an operationally representative environment, so that we can get early feedback from the operators and feed that back. So what's important there is that each of those types of T&E is going back to inform our concept developments and our requirements. There is another element to this which I haven't put on the diagram, and that is we also intend to put sort of small scale procurements out into service in a more operational sense. And what we're doing there is sort of bypassing the traditional capability acquisition process, because of the fact that this technology moves so quickly. So we want to be able to get it out there, but we still have to meet certain safety and environmental objectives. And Andrew Kerle will talk a lot more about that in his presentation. So I'll leave that to him to talk about. Next slide, thanks. So we've got those different types of T&E activities, but we are also sort of prosecuting three different domains. And it's a real sort of focused effort to look at these three different things. So the first one is understanding the solution space. So we're really trying to understand exactly what capabilities are out there and what we can do with those capabilities. So for a good example is we really want to understand the payload and range. This is fairly sort of fundamental for us. So this chart's showing payload on the y-axis in kilograms, and range in the x-axis. So that's a logarithmic range. So the four lines on the left side will show you the performance of what we're getting from various size typical multi-rotor UAVs. And on the right side, you can see a fixed-wing UAV. Quite a different performance characteristic, obviously quite a substantial range, but much lower payload. And this has been really useful for us because you can see a small red dot sort of in the middle of that left side. And that's a bit of a target for us to where we think the operators actually need something. So by getting this information, and it's actually evidence-based as opposed to looking at information from somebody's brochure or from a website. We've actually got hard and fast data based on test and evaluation. And that's then caused us to then drive development of new systems to try to meet where we see these perceived operational gaps. So in this specific example, we're actually contracting an Australian company to produce a hybrid power system using an internal combustion engine in combination with a battery. We're also investigating mesh networks and alternative navigation systems to look at enhancing the operating range. Next slide. So the other challenge that we have that we're really trying to get our claws into is understanding the regulatory environment. So we're working within primarily DASA, but then Navy has their own interpretation of regulations beyond that. And we're also having to play in CASA's airspace at times as well. So we need to fully understand what the limitations and regulations are around that. And probably one of the most fundamental issues for us is because we're going beyond visual line of sight, BV loss, we do have an obligation to make sure that we don't run into other crewed aircraft or uncrewed aircraft or even ships on the surface of the ocean. So that's driven us to look at alternative physical systems, so ADS-B and IFF Mode 3C, that sort of stuff, detect and avoid systems, whether that's visual or others, and also we're investigating voice relay systems so we can communicate to other air vehicles while we're much further away than our visual line of sight. Next slide. And then the final area, of course, and this perhaps the most important, is understanding the problem space, so understanding what our operators actually need. And so what we're doing is engaging with our operators during a lot of our DT&E and preview T&E, and also conducting these operational assessments. Now, sometimes we're involved in those operational assessments. For example, we did a shore-to-ship delivery onto HMAS Choules during Talisman Sabre earlier in the year. But we were involved with the operators, and we're getting useful feedback from them throughout that process. So really what we're doing is using T&E to understand what the user's needs are in this case. Next slide. This isn't really T&E, but it's really important for the program that we're involved with, and that is that having an adaptive commercial structure to actually support this. So obviously the T&E is driving changes in the direction of our project, which means we need to change where we're spending our money. So it's been really refreshing to have a good project manager in Canberra that's set up a system where we can, we've got funds allocated, but we can identify where those funds are going and change direction as we go. And that means that we're making really good decisions based on really good information that we're getting out of test and evaluation. Next slide. So integrating all this together, I think this simple diagram really shows those three big elements that we're focusing on trying to get further information. That's the operator needs. We're trying to understand the regulatory environment and how the operator needs work against that, and also trying to understand what the capabilities are of the systems that are out there and what modifications we can make to either meet the operator needs or the regulatory environment. So you can see those three elements are all working against each other, and T&E really provides the link between all of those elements. And again, the whole idea is we're making decisions on facts and not assumptions. Next slide. So concluding from all of this, and I know it's a very brief overview, but I really wanted to get to the flavour of what we're doing, and that is using T&E not just for verification, not just something that you do at the end of the project, but actually using it to learn, and that's actually driving the process that we have, or the program that we have in understanding the requirements, understanding the technology, and understanding the regulatory limitations. So T&E is very much informing our journey and not just a sort of a certification step at the end of the process. So that's the conclusion of my presentation. Thanks for taking the time, and I'll be obviously online ready to answer some questions once Andrew and Wes have presented theirs. Thanks very much.
All right, fantastic, Shane. Thank you very much. I was actually lucky enough to see some of that detail presented at the IndoPac exhibition last week, and I was really excited to see how you and your team shaped the acquisition process to drive the maritime uncrewed logistics capability moving forward. So as mentioned, we will open the floor for questions at the end of the third presentation, but for now I would like to introduce Andrew Kerle to discuss the competition between speed of relevance and certification. So handing over to Andrew.
Thanks, Adam. G'day, everyone. Lots of friends and colleagues on the call, which is nice to see. But for those of you that don't know me, my name's Andrew Kerle. I have the creative nickname Kerlo. Welcome to my short presentation on uncrewed aircraft systems. I'm going to use the term drone interchangeably today just for brevity. Prior to my current employment, I was a test pilot in the Air Force. I spent around 15 years at the Aircraft Research and Development Unit in a variety of different roles, and including a brief stint as the Air Force Chief of Flight Test. Since transitioning out of uniform, I've been continuing to work in test and evaluation within the Army Aviation Systems branch of the CASG. Been in this role for about 2.5 years, and I've worked across 8 different interesting drone acquisition programs, ranging from sub 2 kilogram man-packable systems up to 80 kilogram tactical systems and everything in between. The scope of my presentation is to briefly discuss what's going on in the drone environment at the moment, give you a summary of the systems that my program office is delivering, we're delivering to Army and Air Force, and talk a little bit about regulation and certification in the context of the current drone environment. I'll then finish with some reflections on some of the opportunities that we might have to sharpen the pencil, if you like, on the acquisition engineering activities so that we might actually start delivering minimum viable products and minimum viable capabilities in short periods of time. Heavily caveated, of course, that this is just Kerlo's opinion, and there's a variety of opinions on this topic at the moment. Next slide. So the drone zeitgeist. I'm sure most of us are broadly aware of what's happening in the drone industry at the moment. We see impressive operations conducted in Ukraine and other parts of the world most days on the news. And we also recognise that defence is making its own significant investment and interest into different types of uncrewed systems. There's a huge amount of effort going into technology development across a wide range of these capabilities, ranging from low TRL, low-cost systems, like the one you can see at the top of this slide. There's the system that is a cardboard, flat-packed, built by SciPac Systems in Melbourne for the Ukraine, for precision payload delivery. And then all the way at the other end of the scale, high TRL, high-cost, complex systems like the Triton and the Ghostbat. Unfortunately, not areas I'm working in at the moment. Vendors are also offering families of systems that operate a variety of different air vehicle sizes, different sensors and different effects. But all of those are often operated from a common ground station, common control interface, which is really interesting. Small systems are all now also being developed to have resistance to GPS denial and offensive EW effects. And of course, we've all seen that weaponization is becoming quite prolific. All of this is increasingly empowered by artificial intelligence and machine learning. So there's really rapid growth and expansion of capabilities becoming available to defence. Next slide. So whilst technology is surging in pace, capability and complexity, government, both here and in the other Five Eyes nations, is directing us to acquire and sustain these capabilities more rapidly, underpinned by the MVP-MVC concept. At a strategic level, government released the Sovereign Defence Industrial Priorities, or SDIPs, coincident with the National Defence Strategy, and 2 of the 7 of those directly relate to this discussion. Number 5 seeks to invigorate Australian industry to build, design, manufacture autonomous systems, and number 7 discusses the needs for sovereign test and evaluation, sovereign certification, and systems assurance. So in my experience, whilst there's a very good intent to deliver MVP and MVC, we still have quite a ways to go at the tactical level to make sure that we embed those concepts into our business as usual. Next slide. So the concept of speed of relevance is something that lots of people are talking about, and it's of course a function of our strategic environment. Clearly, there is a difference between the speed of relevance for the people of Ukraine than the speed of relevance for the people of Australia. But it's certainly impressive what is happening over there, and we can be inspired by some of their achievements. Drone design, counter design, and counter design is iterating at a mind-blowing speed. It's widely reported that drone hardware and software is being designed at the unit level, literally on the front line, and iterates over periods that are measured in days and weeks, not months and years. Notwithstanding, despite the obvious differences in context, we generally acknowledge that the Australian defence industry is being encouraged to accelerate the way that we deliver capability to defence. Interestingly, just last Friday, some of you may have seen Pete Hegseth announce major reforms to the US equivalent of the One Defence Capability System. It's an interesting speech, but perhaps one of the things that I found most meaningful was the statement that he views the current pace of acquisition to be moving at the pace of paperwork rather than at the pace of relevance. So, of course, in our Australian context, the speed of relevance is derived from the National Defence Strategy. So, in the context for this brief, let's recognise the following. Uncrewed systems capabilities are evolving exponentially, which increases the availability of systems and options for us. Artificial intelligence is empowering that evolution and advancing the different capability effects. And small technology companies are emerging as major players in the market, designing and prototyping pretty cool capabilities. So it's not just the domain of the major primes anymore with their deep pockets. So with that in mind, I'll move on to talk about what we are doing at the moment in the project office and the engineering activities that we undertake to deliver capabilities into service. Next slide. Well, there it is, that's fine. Okay, so over the last 3 to 5 years, the UAS workforce within CASG has evolved from a handful of people working on a couple of small projects embedded within the cargo helicopter program office into what is now a single dedicated uncrewed aircraft systems program office. We have 3 branches, each headed by an EL2 director. Futures and Policy is the first, which is focusing on pre-Gate 2 work and developing program office policy and developing a bespoke engineering management system. Then we have the 2 engineering teams, which are the Smalls team and the Tactical team. The Smalls team are focusing on air vehicles that have a weight less than 25 kilograms, classifying them in the Smalls class. And the Tactical team are supporting 20 Regiment in the replacement of the Shadow capability. Within both of those teams, we combine acquisition and sustainment engineering efforts into one business unit. So this was a significant organisational change, and it was rolled out in a few phases. It commenced only in August of this year, and the aspiration is to finalise the change by early next year. So we're kind of midway at the midpoint. Within the Smalls team, there are currently 5 systems that are in service in Army and Air Force, and the 2 new systems that have been delivered under DEF 129. Heath Rowe, also on the call, a good friend and colleague and AeroPM employee, as well as the test SME in the Tactical team. Next slide. So very briefly on the Tactical program, or Heath's program as I'll call it. The system is being acquired is called the Integrator. The vendor is In Situ Pacific, which is a Boeing company, and they're based in Brisbane. If it looks familiar to you, it's because it's an evolution of the Scan Eagle, but it's been adapted for land-based operations. So whilst there is some heritage in the components of the system and in the operating concept, the Integrator project is actually highly developmental. We're integrating Australian design payloads, Australian unique mobile launch and recovery systems, and integrating with existing command and control infrastructure that is in service with Army at the moment. Interestingly, as an aside, we conducted a tailored accreditation of the flight training device that resulted in Mayo approval for remote pilots to actually collect flying currency credits on a like-for-like basis, which was a good step. Anyway, there's lots of lessons to be learnt from that program, and I'll defer any other questions on that to Heath as the expert. Next slide. In the small space, we're delivering the Quantum Systems R24 Vector 2-in-1 and the SciPac Systems Corvo X. Both of these systems feature vertical launch. They then translate into forward fixed wing flight to optimize speed and endurance. And then during recovery, they retransition back to a vertical landing. The Vector 2-in-1, which is on the screen at the moment, is called that because it can be reconfigured rapidly from a fixed wing configuration that you see on the left to a multi-rotor configuration you see on the right. That is achieved simply by swapping the wings and the tailboom to copter arms, and you're set for operations in a different configuration. So the R24 is an iteration of a widely used R20 variant, but of course, Defence decided to add on some options, which has created some complexity. The first of which is ADS-B to aid integration into shared airspace. The second is artificial intelligence module, which is attached to the payload that provides moving target detection and recognition capability. And then finally, we added a Blue SDR radio, which permits us to broadcast missions live to the L3 Harris Rover 6 communications network. For the Air Force, they are also being equipped with a ground tether unit for the multi-rotor configuration. So on the bottom right there, you can see a depiction of it, but it's effectively a power cable that goes up to the air vehicle whilst it's in flight, and that permits persistence for up to 24 hours. So we're bringing 100 of these systems into service. They're going to be used both by Army and Air Force units, and there will be 18 different units receiving them. So it's a very broad use case. Next slide. The second system we're delivering is the SIPAC Systems Corvo X, Australian company, clean sheet design, which was developed and manufactured down in Melbourne. It's smaller and lighter than the Vector, and it can be carried in a backpack, and it's controlled through a Samsung smartphone. Its fun feature is that you can power it on and pre-flight it just by shaking the air vehicle. And during recovery, the remote pilot can grab it as it descends vertically and hovers at shoulder height. So that will be particularly useful in rugged terrains. We are delivering 20 of these systems to 7 different units across Army. Next slide. So this slide is just a bit of a snapshot or a comparison, if you like, of the different projects I've worked on in the last 12 to 24 months. Don't think too deeply on the slides because the values that I put there are not quantitative. My intention is just to show that the scale of variation in each of the project's scope, budget, and schedule. It's entirely subjective. The bottom line, the ASCA Sovereign Drone project, is also a really interesting one. We supported it late last year. It was an ASCA effort. So it was not directly supported by my program office, but we did provide some SME support for project management, commercial outcomes, and test. So it wasn't delivered under ASDEFCON or within the CASG ecosystem, and that actually makes it a very interesting data point for me. We gain valuable insight into what could be achieved if we have an MVP type mindset for what are understandably very simple sub 2 kilogram systems. Those systems are now available for purchase by units via a standing offer panel. And the process from design, concept to prototyping, testing, and then mass production, by mass I mean 100 units within 12 months, that entire process took 12 months. So I think it was quite a successful outcome. So that's the fun part of the brief done and dusted. I apologise. Next, we're going to talk a little bit about certification and regulations and what I call the importance of a capital letter. So those of us on this call with a background in flight test have a deep understanding of airworthiness and certification of crewed aircraft, and I call this capital C certification. For those not familiar, this is where crewed aircraft are subject to initial and continuing airworthiness requirements prescribed by the Defence Aviation Safety Regulations. And importantly, in the context of this presentation, DASA also prescribe aircraft technical design requirements in the Design Requirements Manual. These requirements are both extensive and specific. It may come as no surprise to the audience that there are no specific technical design requirements for drones in that manual. There is a chapter, it's been reserved for future use, but currently it's only a placeholder. It's also important to note that the purpose of the DASA is to assure safety by design. Mission success is not really within the scope. Now, that's not to say that DASA doesn't prescribe safety rules for drone operations, and I'll get to that shortly. My point here is what I refer to as capital C certification is the airworthiness of crewed aviation systems, and that is different to what I'm going to talk about next, which is lowercase c certification. Next slide. So certification for the drone systems that we are acquiring at the program office are established through the defence engineering requirements laid out in policy at a defence level and then at CASG subordinate levels. The overall goal of that policy is to provide a framework around material system certification. This policy applies to all defence material systems in a scalable manner, from land vehicles to body armour and so on and so forth. In the case of small drones at the program office, we utilise the engineering management system of the Army Aviation Systems branch, which is the same EMS that supports Army helicopter operations. Now, noting that our organisation still has that new car smell, we obviously have a need to adapt that policy and process for our operations. And that is work that's currently being undertaken by the Office of the Chief Engineer, who's developing an engineering handbook to tailor that EMS. So this work is ongoing, and without attempting to diminish the importance of material certification, I'd like to distinguish between the two by calling this small C certification. And at a high level, what does that mean? CASG policy says that you have to have a certification plan and an associated certification basis. The basis must identify technical requirements. The requirements must be verified. And finally, the basis must be maintained and monitored in service. The picture on the left-hand side of this slide is an overview of the certification basis for the vector. Now, each one of these sub-elements represents quite a significant body of work. For the vendor to develop ASDEFCON submissions, and for the program office to review them, and as is often the case, reject them a few times before we approve them. Without wanting to air our dirty laundry, a good example of the effort that goes into these things is that it took us over 12 months to approve a safety case for a sub 10 kilogram drone that's currently in service. So we are expending a lot of effort in building the certification evidence to provide assurance that the system meets defined technical requirements. Some of these are safety requirements, and some of them are legislated safety requirements. Of course, the WHS Act obligations are still fundamental to the work we do, but what my point is, we're not doing capital C certification. Now, I acknowledge I'm making some rather gross generalisations to make a point. There is obvious nuance and detail that's beyond the scope of this short brief, but I really do think there are opportunities for us to carve out meaningful amounts of process and still arrive at the same point, but we can do that a bit more quickly. Not so much what we are doing on that V diagram on the right in systems engineering, but more how we do that. Next slide. So a quick side note on what the regulator requires for drone operations. The applicable regulation is essentially a category system where the level of rigour required to approve the operation is proportionate to the risk and complexity of the intended use. The intention is to assure safety, and it applies a risk management framework in the context of, one, risk to other airspace users, those airspace users being crewed platforms, and two, the risk to people on the ground and critical infrastructure. At the moment, the categories are mostly aligned to air vehicle mass, but this is going to change soon to align with contemporary civil standards that are emerging. And these standards are more complex, and they take into account total kinetic energy of the system, different classes of airspace, measured population density within the intended operating area, and a few other things. I'm sure we will move to that eventually. But in the current state, the categories range from the open category, which, equivalent to, say, taking a Mavic Pro with you on your holiday to Bali, all the way through to a certified category. Although to my knowledge, there are no certified drones yet. It's trending that way, in particular, as Shane brought up, the development of autonomous sense and avoid systems. But between those two rather large bookends, there is a specific category. And typically most drones will operate in the specific category, whether it's a complex system like the Triton or Ghost Bat, or a simple system like the Vector or the Corvo. I won't bother you with more detail on the regulations other than to say that most small drones initially and potentially for the life of type will operate in the specific type B category. Next slide. So specific type B is what I call the sandpits. DASA will call them standard scenarios. It's essentially a set of rules that must be implemented by the user group to adequately manage risk to other airspace users and people on the ground. If you play by the rules, you're approved to play within the bounds of that particular sandpit. So through publishing the rules, DASA delegates the drone approval down to command. not by the regulator, which brings self-evident benefits. There are a number of sandpits, each with their own rules. The key point is that the category system allows us to apply a scalable set of rules proportionate to the risk and complexity of the intended operations. So, for example, operating a sub-25 kilogram drone on a defence range at Puckapunyal carries fewer rules than operating the integrator in Class G airspace in southeast Queensland. The underlying philosophy of these regulations is within the guidance material, and there are two key points. Firstly, the regulator recognises that most DASAR were created in the context of crewed aircraft, so the burden of full compliance may be disproportionate to the safety benefit for drone operations and for drone design. Secondly, specific type drones will exhibit deficiencies in their design compared to certified drones. So the safety risk due to these deficiencies is managed rather through operational constraints rather than through design requirements. So more and more sandpits are being approved, and DASAR will release another significant update in July of next year, and that's going to include the ability to perform G-regard operations in Class G airspace and also expands the rules for the weaponisation of drones. Next slide. So I've done a lot of talking, and I guess you're thinking to yourself, yeah, so what, Kerle? Well, these are just my musings, and there's a variety of opinions on where do we go from here to achieve MVP and MVC. But at the core of both Big C and Little C certification is the concept of assurance, where assurance means to give confidence to someone or to something. What we need is greater clarity on defining who is responsible to be able to make risk-based capability decisions. And this is more complex than it sounds, but it's necessary, so that we can work out how much assurance is actually enough to support those decisions. So of course I've made up another phrase, and I'm calling it minimum viable assurance. I'm not sure it's going to catch on, but I think it kind of captures what I'm trying to say. We've seen that the DASAR implements a risk-based scalable framework to approve drone operations. I think there's an opportunity to apply the same mindset to small C certification and the engineering activities within our program office to ensure that what we do is necessary and adds value to the user groups. There's a big difference between how much confidence we need in the design of the 80 kilogram integrator compared to that of the 1.5 kilogram Corvo X. Or as our American friends have been saying, we need to deliver at the speed of relevance, not at the speed of paperwork. Sure, there is absolutely some complexity in this area, but as someone smarter than me once said, in the chaos, there is opportunity, something we talk about in the office often. So thanks for your time. Appreciate the participation. Feel free to reach out to me via the AeroPM office or questions at the end of this, or hopefully I'll see a lot of you in the next couple of weeks at the Defence T&E Symposium. Thank you.
All right. Thank you, Kerle. I was lucky enough to work with Andrew on the test program for the AP3CEW over in Texas in early 2010. We were both looking a lot younger back then, but your experience at the time really drove the success of our program, so thank you. I was also happy to see another photo of Kieran Joyce holding a drone in your presentation. I think there are photos of him holding drones almost everywhere in defence now. So, last, I'd like to introduce Wes Dowling, who is going to discuss the importance of good critical operational issues. So, handing over to Wes.
Good afternoon, ladies and gentlemen, and thanks for your time. I work within the Headquarters Surveillance and Response Group's Test and Evaluation Accountable Unit as a senior test practitioner. And today I'm going to talk about the importance of good critical operational issues. Next slide, please. I'll quickly skim through an outline of operational test and evaluation, and then we'll dive into critical operational issues and their importance within projects. So OT&E is predominantly conducted at discrete points throughout a project's acquisition lifecycle when a system or system increment is delivered to a defence operating unit as a capability. And we aim to evaluate whether the capability system meets Defence's need as envisaged within the operational concept document. Unfortunately, we can be a CASG project manager's nemesis because after they've executed their grueling product development lifecycle, OT&E tends to be all that stands between them achieving a capability declaration. And that could be IOC, FOC, and there are various other permutations like OC states, operational releases, and so forth, depending on how the project has been structured. And that's why OT&E is so important. It's an independent evaluation representing the uniformed operator community on whether the system as delivered will enable them to achieve their mission. OT&E test reports are combined with other project artifacts under a covering minute and informs the capability chain from the local force element officer commanding right through to the service chief of the degree to which the capability system is operationally effective and suitable. And these are key words here, and I'll delve further into those on the next slide. And so if that's been successful, then the service component commanders receive direction to maintain readiness of the new capability, and CJOPS is informed that it's available for tasking. So post OT&E, the train has left the station, and there's now an expectation that CJOPS can task an operational unit to deploy this system operationally. OT&E can also be requested following a significant in-service upgrade to inform a full service release decision, or to augment a unit's deployment to an exercise, to supersize the post-activity report, and generate some high-fidelity OQE to inform preparedness reporting. For these activities, though, you'd refer to in-service definition documents rather than the project definition documents, which I'll be referring to within this presentation. Next slide, please, Dale. So I've got the operational effectiveness and suitability definitions here. There are many definitions out there with subtle changes. However, I quite like the US Navy definitions. I'll let you quickly skim through those. But as a summary, for operational effectiveness, can we employ the system to achieve the mission in a representative context? And operational suitability, can we deploy and employ the system within the notice that we're given and sustain our mission effectiveness over time with the operational availability and interoperability that we need and for as long as we need. Next slide, please. So we've covered when OT&E is done, and we know philosophically what it's aiming to do in evaluating effectiveness and suitability, and we know who it informs. So how do we know what to actually test? Well, at project conception, an operational concept document is created to outline the operational context and define the quality attributes of a system that would address the established need. And the scope of the eventual OT&E test program is shaped here in the OCD at the very start of the project in the form of critical operational issues, or COI. So the COI form the basis of our test planning, conduct and reporting, and are ultimately how we frame a capabilities, systems, effectiveness and suitability to senior leadership. For the engineers on the call, these are our tier 1 requirements that we need to operationally validate. And we decompose the COI into measures of effectiveness and suitability as our next tier. We can think of MOE as the mission task elements to achieve the mission, or it can be helpful to think of them as the high-level business processes to achieve the mission. So if any particular one has an issue or deficiency, the ability to functionally achieve the mission is at risk. MOS are often aligned with fundamental inputs to capability. So think of training, logistics, reliability, availability, maintainability, facilities, publications, and so forth, but also aspects such as deployability, transportability, security, survivability, and environmental resilience. So the 10th should detail the MOE and MOS that will provide coverage to answer our COI. We decompose further from there for our measures of performance, which are sometimes referred to as measures of assessment in the US. And these represent our discrete data points we intend to capture during an OT&E test program to answer our MOE and MOS. And these are developed within our test plans. And there can be many test plans for a project that are subordinate to the 10th in order to provide adequate coverage of all the MOE and MOS, which in turn will answer the COI. So in summary, OT&E test programs are framed by the OCD, the 10th, and our test plans. But all our measures stem from the COIs defined up front in the OCD. Next slide, please, Dale. So what should COIs look like? So COIs are a set of yes or no questions that will inform the capability manager of whether a system can achieve its assigned missions. And it may sound obvious from the name, not to everyone, but they must be critical, they must be operational, and they must be mission-based. And all these points infer that operator input for COI development is absolutely essential. I'd suggest they're unlikely to hit the mark without direct operator involvement in their creation. Many systems will only have about 3 COIs. Most systems are just unable to achieve more than 3 independent missions. Complex multi-role systems may have 5 or so, but you would definitely want to start questioning the criticality and mission-based nature of the COIs if there were more than 5. Critical operational issues should be formed through analysis of the system's intended standard mission threads. And as a helpful rule of thumb, it can help to use a phrasing structure which articulates the system that you've got, the required operating capability, and the projected operating environment, operational environment. As a bit of a side note, it's also worth mentioning here that with the increased take-up of incremental delivery methods, such as those described in the earlier presentations, it can be beneficial to structure your COIs to complement this project structure. So your minimum viable capability, or MVC, must at a minimum enable an operating unit to achieve at least 1 mission to qualify as being a viable capability. Therefore, if you've baked in a COI within the OCD that aligns with this mission, then it provides an inherent traceability between the increment you're delivering and at least 1 COI that is fully resolvable within an OT&E test program. Conversely, it becomes problematic if a project is attempting to achieve a capability declaration with an MVC which doesn't resolve any COIs. Next slide, please. So I've got some examples of good COIs here, and as we run through each of these, it's very clear. We've got the required operating capability and operating environment. It's also very clear that if these capability systems can't achieve these, we shouldn't be accepting them into service. So we'll quickly run through. We've got the ATM capability system, effective approach control, all defence fixed-based aerodromes. We've got an ABM capability system, produce a recognised air picture, intended area of operation. So when you see phrases like area of operation, area of interest, intended environment, that's not a cop-out. The expectation is that elsewhere in the OCD, in the mission scenarios and vignettes, that this would be elaborated upon to provide that detail. Tactical UAV system, adequate coverage, ground manoeuvre brigade commander's area of interest. V-22, assault support, intended environment, and so forth. Next slide, please, Dale. And here are some examples of some poor COIs. And now looking at these are all real examples which we have within OCDs over the last few years. I've anonymised them somewhat. These COI are largely not mission or role related. There's no indication of the operational environment. They're vague, and to a large extent, they're not operationally testable. So if we look at that first one there, adaptable, what does that mean? Managing growth, how would we operationally test that? There's then broad spectrum of roles and mission, again, very vague. Then we get to these next two, interfacing with the required external systems and controlling the radar. These are probably more at the MOE level. They're not missions unto themselves. And then again, the last one there, very vague on what the mission actually is that this training system is aiming to go after. Next slide, please, Dale. So what do poor COIs mean in practice? Well, there are 2 key issues that arise with poor COIs. Excessive measures leading to protracted test programs and incomplete, ambiguous or misleading advice to the capability manager. For the first issue, I mentioned earlier that the COI become the tier 1 requirements that need to be answered. And so a lot of work goes into decomposing them into MOE and MOS and then MOP. And this is usually achieved through extended research and many, many workshops with various SMEs in the field and project stakeholders. And this can amount to a substantial resource burden, human resource burden, throughout the project. You're pulling all of these people in to help you out instead of doing their day jobs. And for all this effort, you end up with an inflated test program exceeding the timeframe budgeted for OT&E conduct and reporting. And this will likely translate to a direct delay to a capability declaration milestone, which can be pretty untidy. For the second issue, poor COIs will lead to poor test outcomes and conclusions that can be reached in reporting. And the capability manager, when they're flicking through the executive summary, may realise this, or their delegates may realise this and require more testing to give them confidence that the mission can be achieved, or they may be forced into a position where there's no more time or funding and they need to waive further testing and deliberately retain operating risk that may be realised in service. In the worst case, it slips through to the keeper and no one realises that the COIs don't reflect the mission, and there's an unknown retention of operational risk when the system formally enters service. Next slide. But there is a good news story. If, as a test practitioner, you are confronted with poor COI, you can and should correct them throughout the project. It does require a few 06 and 07 signatures, but it's definitely worth it to reset the framework for a higher quality and more efficient test program that will answer the right questions for senior leadership and better advocate for the operational units who will ultimately be tasked with operating this kit. And I've definitely encountered recently an increased willingness within projects to make changes to COIs well into the project lifecycle, whereas in the past, the notion of opening up an OCD may have been more challenging to achieve. But you have to create an opportunity to make this change. So make particular efforts to critically review the COI as part of periodic temp reviews. This is normally every 2 years, but that comes around fairly quickly for major projects. And critically review the COI during initial scoping activities for your test program. Obviously, you'll be using them at this point, but ask yourself the questions, are these actually good COIs? And if you do find that they are inadequate, it's important that the risk this poses to the project is framed in the context of the issues on the previous slide, project delays and poor advice to senior leadership. Ideally, we'd always be able to update the COI within the OCD. And this should definitely be the preference for traceability. However, for many reasons, this isn't always achievable. Sometimes changing the OCD automatically triggers a contract change proposal for the delivery agency, for example, which can be very costly. In which case, look to identify and justify the change within the temp. To avoid confusion though, at the end of the project, and I stress this when the OT&E test report arrives, this should be supported by a decision brief to the project sponsor prior to carrying out to gain their agreement on the proposed change. And we've had recent success with this method for a major project. So that concludes my presentation. Hopefully it's given you a few tips and tricks for when you're faced with compiling an OCD and you get down to page 143 and wonder what to do with that table called COIs, or you're on the receiving end of an average OCD on how to deal with COIs. As always though, it's really important that you reach out to the relevant test and evaluation accountable unit to help you in the development process. And otherwise, I know the Air Force Headquarters Test and Evaluation Cell has some fantastic people in there who are also more than happy to help you out. So thank you all for listening, greatly appreciated, and I'll pass it back to Adam.
Fantastic. Thank you, Wes, for helping us all grasp the importance of good COIs within an OT&E test program. Well, I personally know that the work that the whole team up there is doing in Newcastle within the SRG group is absolutely vital to the future capability of SRG, and hopefully, thanks to your presentation, future OCD authors are able to shape COIs to make OT&E easy to scope in the future, especially with incremental capability delivery. So, on that, what we will do now is move on to the questions. So we have a couple of questions that have been raised in the chat already. So the first one is from Michael Manfield. So thanks, Michael. And the question's for Shane. I think it's for Shane, or Kerle? Yeah, for Shane. So does your approach, Shane, seem to be gaining traction across the defence T&E enterprise?
Yeah, I saw that question there. I'm not sure I can actually answer it on behalf of Defence. I know, at least within Navy, there has been some publications that have been produced in recent years that try to introduce this more agile approach, and recognising that we need to move faster, especially when the technology is moving fast, and balance that against the risk, as Kerle was sort of mentioning, that, you know, these 8-kilogram systems inherently don't carry the same risk that you do with an 80-kilogram system. So I think there is a bit of a change in mindset. There are some publications pointing in that direction, but I haven't been working broadly enough within Defence to sort of answer whether that has been adopted in other places.
Shane, can I just ask, after Rubes' presentation, IndoPac, we had a Special Forces commander reach out to you to ask for, for further discussion. So obviously, Special Forces have been doing rapid acquisitions like this for a while, but maybe not with the same level of rigor from a T&E perspective than you guys are actually conducting right now. So there's obviously room to move for your program across different parts of defence as well.
Yeah, there definitely is. I mean, we are sort of trying to inject ourselves into different parts of the Navy primarily, but potentially, getting more involved with Army logistics as well. And, we've got a fairly small team, but experienced team for test and evaluation. So we want to be able to sort of offer that almost as a service. So we're sort of acting a little bit like a small startup, just within our little team. But, if we're offering those services, we're also asking for money to come along with that. But there's a couple of projects within Navy, for example, for surveillance and reconnaissance, that have shown some interest. So we may help out with that. It just makes sense to use the skills where they're available, and it just comes down to a matter of capacity then.
Yeah, fantastic. Thank you. The next question is from Lauren. Hopefully, Lauren understands that Kerle is a pilot, not an engineer, but we'll see how Kerle is answering this question. So, Kerle, do you have any comments on neglecting software assurance applicability?
Well, thanks for asking the question that way, Friz. Hi, Lauren. Nice to hear from you again. I think your question really taps into my point about big C versus little c certification, where in aircraft crewed system certification, there are very strict requirements on software assurance levels and the amount of engineering effort that goes into developing those to certain standards and codes. Whereas in the context of drones, and specifically small drones, we don't neglect it, as Friz put it, but rather we consider the risk of malfunctioning software within our system safety program, as opposed to within the context of the software assurance level. So I hope that answers your question.
It does, and thank you very much. I come from a world that really cares about software and the things that go bump in the night, and trying to find out what happened and trying to find somebody in the software area that can trace that. Thank you.
No worries. Well, thank you for the question. So the next question is from Dan at Nova. Is there significant regulatory flexibility in the Australian environment to conduct relevant R&D and T&E to provide the required assurance for UAS? The question is pertinent for both civil and or defence environments to enable the aspirations in relation to sovereign supply chain of operationally relevant capabilities of defence at the speed of relevance. So coming back to speed of relevance, Kerle, this one might be targeted at you.
Yeah, no worries. Hi, Dan. Nice to hear from you, mate. So I suppose there are two aspects to this question. One is the defence environment, and one's the civil environment. On behalf of the defence environment, there is a sandpit, if you like, or a standard scenario for experimentation that largely confines your operations to, exclusive use airspace and sparsely populated areas on the ground and that kind of thing. But again, there is major updates coming to those regulations soon, and I think the sentiment that you're expressing is, hey, we need a bit more flexibility, and I would wholeheartedly agree with that, and hopefully that will be reflected in updates and upgrades to regulations over the next 12 months. I can't really speak from a civil perspective, and I suspect you're far more well-versed in that than I am, but that is my response in the context of defence.
All right. Dan says, thanks, Kerle. Then we have one final question again from Michael. So for Shane, is the project looking at delivery methods of submarines or to submarines?
Yeah, the answer is yes. I can't say too much detail, but we've been talking within the maritime warfare area to our submarine brethren. And yeah, that is a logistics issue that is within the scope of our project, is delivering stores to submarines and small boats and to shore. So yeah, that's we're hoping to do some testing next year.
Well, it sounds very exciting, Shane. It's a very cool program that you're on. All right, so we're out of questions from the chat. Does anyone from the floor have any further questions they'd like to ask one of our three experts? No? All right. Well then, if there are no further questions, then I'd like to thank our three presenters for their time today, and I'd like to thank you all for dialing into our AeroPM Learning Together program. So please keep an eye out for our next Learning Together presentation that will occur in early February 2026. Until then, I hope you all have a relaxing run through to the festive season, and thank you all for dialing in.
Thank you.